I'm Dr. Julian Hungerford, a senior application scientist here at Micromeridics. Micromeridics is the world's leading supplier of high-performance systems to characterize particles, powders, and porous materials. Today we're going to be looking at our 3-flex analyzer. The 3-flex is capable of analyzing both physisorption and chemisorption. In this video we're going to be looking at physisorption. The 3-flex features hard seal valves and chemically resistant metal seals that allow for collecting adsorption isotherms starting from 10 to the -9 p/p0. This allows the 3-flex to achieve the lowest vacuum level in the industry. The 3-flex has the greatest precision when determining surface area, pore volume, and pore size distribution. The p0 port provides continuous monitoring of saturation pressure during an experiment, and isothermal jackets ensure that your samples always remain submerged in liquid nitrogen. Analysis ports can be configured for krypton analysis, which is essential for the analysis of low surface area materials. The 3-flex can analyze the widest range of gases and vapors due to its chemical resistivity. An enhanced chemical resistant model is also available to further increase that range. A list of some of the gases and vapors that can be used in the standard 3-flex and enhanced chemical resistance model is displayed on the screen. Please inquire about any gases or vapors that are not on the list. Now that we have discussed some of the advantages of the 3-flex, we will talk about how to load and run a sample. For this demo, we will be conducting a nitrogen physisorption experiment. First, take an empty sample tube and weigh it, recording the empty sample tube mass. Next, load the sample into the sample tube using a funnel if necessary for powdered materials. Use a pipe cleaner to ensure that no particulates are stuck to the side of the tube. Record the filled sample tube mass. You can repeat this process for up to 3 samples. Next, take the sample tubes to the instrument and place the isothermal jackets onto the sample tubes. Load your sample tubes into the sample holder. Place the p0 tube into the proper position within the sample holder. Once the samples are properly loaded, fill a dewar with liquid nitrogen, making sure to wear the proper PPE. Place the filled dewar onto the elevator. Lastly, place the splash shield on the unit. The samples are now ready for analysis. Let's look at setting up the files in the software. Begin by opening the 3-flex software. Ensure that the instrument is set to physical adsorption mode by selecting Unit 1, Physical Adsorption. To begin the analysis, select Unit 1, Sample Analysis. Then load the sample files that have the recorded masses and analysis conditions. Press Start to begin the analysis. The instrument will automatically raise and lower the elevator when the time is appropriate. Activation conditions, analysis conditions, and report options can be preloaded into the sample file, saving you time during an analysis. While the instrument is running, let's talk about nitrogen physisorption and BET analysis. First, the instrument pulls a vacuum and the sample tube and system are evacuated. Next, helium is brought into the system to determine the volume that the sample is not occupying. The helium is then removed so the analysis gas can be dosed into the sample tube. Users have the option of performing this free space analysis before or after adsorption of the analysis gas. Analysis gas is then dosed into the sample tube while the system tracks the pressure to determine the quantity of gas adsorbed. This is then plotted as quantity adsorbed versus pressure to develop an isotherm. From the isotherm, sample information such as BET surface area, pore volume, and pore size distribution can be determined. Depending on your sample, the region to collect adsorption data can vary. In the lowest pressure region of the isotherm, below 0.1 p/p0, the BET surface area of microporous materials can be determined. The BET surface area of mesoporous materials is determined between 0.05 and 0.3 p/p0, the standard BET range. Pore volume is determined once all pores are filled. This occurs at the highest values of p/p0 as it approaches 1. Pore size distribution information is obtained using different regions of the isotherm depending on which technique is used. The displayed graphic shows some of the common techniques that are used and where data collection is required to determine the desired material properties. Now let's look at the software features of the 3Flex. Methods can be created that allow you to save time during the setup of analyses for similar samples. The 3Flex will come preloaded with a variety of methods for our standard reference materials. Once an analysis is complete, reporting features can be used to perform data reduction on your samples. Just navigate to the sample file and press Open. There will be a wide variety of reporting options for different methods for determining material surface area, pore volume, and pore size distribution. Additionally, there is the option of creating your own advanced reports through the creation of Python scripts. Let's navigate to BET and see how easy it is to change the pressure range fit. When using the 3Flex, samples should first be activated prior to testing. At Micromeritics, we have a variety of different equipment for degassing your samples. One option is the Flow Prep, a simple and cost-effective sample preparation unit that continuously purges the sample at elevated temperature to remove weakly bound contaminants. Another option is the Manual Vac Prep, which pulls a vacuum onto the sample while heating to a fixed temperature across 6 ports, allowing it to remove contaminants. Lastly, we have the Smart Vac Prep, which allows you to set up pre-programmed degas conditions that are independent for each sample port. That is just a quick demonstration on how the 3Flex can be used to collect a nitrogen Physisorption experiment in your lab. If you have any additional questions or would like to speak to someone about your particular application, fill out the form linked below or reach out to your sales representative.